Good morning, children. Welcome to today's class. Today we are going to do activity on compressibility of matter. There are three states of matter, you know that: solid, liquid and gas. And for these three states of matter, we will see how will be the compressibility. Okay, so let's get started. For this, we need three disposal syringes like this. Okay, this is easily available in market. For solid, we are going to use chalk. Okay, you can see chalk pieces that will act as solid. For liquid, any liquid we can take. Here we are going to use water, and in the water, to make it colored so that it can be easily visible, we are going to add few drop of ink in it. I'm adding few drop of ink in this so that nice blue color we are getting, which is easily visible through the glass. Okay, next, for gas we are going to use this incense sticks, and from the smoke of the incense stick, we are going to use as gas. Okay, so these three we require. Achha, let's start. First of all, this is the piston of disposal syringe. This is the piston. So here I am going to put the chalk pieces inside the, you can see it is solid, so to break it I have to put pressure on it. Okay, I have to apply force, so that only we are going to do. Need to make it smaller pieces we need. So after breaking this, I'm going to put this into this syringe. You can see I have put this chalk pieces in the syringe. Now I will be putting the piston inside this, and slowly I am going to press it. You can see here, after applying pressure, I am getting the dust form of the chalk pieces. The pieces has been broken as I have applied force in it. Okay, and now again I am pressing, I am applying force continuously, but I cannot press it more. Okay, it's the piston is here only fixed at the you can see the marks. So here up to 1 I have pressed it, but after that it cannot be pressed more. That means from this we can say that it is very less compressible, or rather it is, I cannot compress it, or compressibility of solid is almost negligible. It's not it cannot be compressed much. Okay, so if instead of chalk pieces we have taken suppose any other solid like iron piece or like that, so any hard metal, then that much also we couldn't have compress it. Okay, so this is for the solid, you can see. Next, the same thing we are going to do with liquid. So here in another syringe I will be taking some, I'm going to take water, colored water I'm taking. up to this it is enough. Now here I have to put my thumb. You can see up to this we have taken, and now I am pressing it gently. See, I'm continuously applying pressure, but up to this it can be compressed up to this only. Okay, so why I am keeping my finger here, otherwise as it is liquid, so it will come out from the syringe. You can see this. After this I cannot compress it, so liquid can be compressed a bit. So compressibility is there for liquid, but after a certain limit only we can compress it. After that it cannot be compressed. Okay, so this is the limit of the compressibility of liquid. Now I'm keeping it in this manner only. Now for gas I have to light this incense stick. This experiment is very easy, so you must try this at your home. All the things are easily available, so you must try it. You can see the smoke. So this smoke we are going to use as gas. So slowly we have to put this inside the you can see it's becoming hazy. That means gas is trapped inside this. And quickly we are going to put the piston inside. See, you can you see the haziness of this syringe? Now I am going to apply pressure in it. You can see easily I can put the piston inside. That means gas is very easily compressible. As there are a lot of gap in between the particles of gases, intermolecular space is. I am pressing the piston, but after a certain limit, see, up to this I could have pressed it, which is much more than that of the solid and liquid. Yes, only a little bit of space is available in between the piston and the syringe. So from this we can say that gases are compressible, easily compressible, as lot of space are there in between the particles of gases. So if we apply pressure, if we compress it, the volume of the gases will decrease, and it can get congested, it can get compressed. Okay, which we cannot see, which we cannot do with liquid, where the intermolecular space is maximum intermolecular space is moderate. So I'm keeping all these three here together so that you can easily understand this three. Okay, see these three different results we have got for this three different states of matter, three different type of matter. Okay, this is for solid, which is almost incompressible. This is liquid, which is slightly compressible, and this is gas, which is easily compressible. Now we are going to do activity on diffusion of gas. Okay, for diffusion of gas is how we will get that, how we can, we know that diffusion is intermixing of particles of gases. Okay, generally for gases we will see the diffusion easily, very fast diffusion will be there for gases, and for liquids also we can get that. So activity on diffusion. For this diffusion of gas, what we are going to do, we have to take two this kind of glasses, okay, which will act as gas jar. Okay, here you can see empty glass I have taken, and this glass already I have made some smoke inside that, which will act as gas. Okay, so how to do that, how to do this, this is very easy. We have to take a piece of paper, just like you can see the piece of paper. So I'm going to show you. So this is a piece of paper we are going to take, so that we need to produce smoke. Okay, why we are making smoke? Because smoke is the color of smoke is black, that's why, grayish or black, that's why it can be easily visible through the glass. So, and while you are doing this, when you are going to do that at your home, be very careful, because you are using fire and all. Okay, so just in this manner we are going to put it inside. You can see black, it's becoming hazy. Hope you can see the smoke inside. So if we keep these two glasses side by side, you can see the difference. You can see the difference between the two glasses. This is empty glass, that means air is there, but we will take it as empty. And this is with smoke. You can see it is a bit hazy. So what we are going to do now, this is a lid or cover. We are going to use this to trap the gas inside. And now slowly we will put another glass on top of this glass. Okay, so these two glasses will be kept in this manner, and slowly we are going to take the lid out. You can see this. In this manner we have to keep these two glasses. So after some time, because of diffusion, what we are going to see, the smoke trapped inside this first glass, which is there at bottom, that will diffuse to this second glass also. Okay, and that also, hope you can see that the smoke inside the which is there in the first glass, in this glass, it's diffusing to this upper glass. Okay, and both of these two are becoming hazy now. So you have to bit careful because you are using the glasses and all, and as you are using fire, for that also be very careful when you are doing this at your home. So this is the diffusion of gas. As kinetic energy of gas is very high, that's why the gas particles uh, that scatter here and there, and that will fill up the whole space available to it. And from this we can conclude one more thing, that the volume of gas is not fixed. Okay, the volume and shape of gas is not fixed. You can see at first we have trapped the gas inside this first gas jar only, first glass only. So that volume only was available for this gas, okay, for the smoke. But when we are adding one more glass, that means now the volume available to the gas is gas becomes double. Okay, and now the gas inside the first glass, that is using the whole volume, that means the volume of the two glasses together, that means now the volume of the gas become double. Okay, so whatever volume we are providing, whatever space we are uh, giving to the gas, it will occupy all space and it will scatter here and there in the whole volume of the gas jar or container, wherever we are keeping that. Okay, so that's it. Now we are going to do the diffusion of water, diffusion of liquid. Okay, for that we need some water. So in this beaker I have taken some water, and for diffusion we are going to use ink. Okay, so just take few drop of ink, and we are going to add this in water. Drop wise I am adding this. Okay, you can see I am not shaking this, I am just keeping it in this manner only without shaking. So slowly you can see the ink is getting spread inside this whole beaker. Slowly it's, if I keep it in this manner, it easily you can see that only one drop I have given, but slowly it's spreading all over in the water. As uh, kinetic energy of liquid is also high, and it will float here and float here and there. That's why when I have added the ink in this water, the ink particles will because of kinetic energy, it will get mixed into the water particles, and slowly it will diffuse, and it will get mixed. After some time it will get mixed in all over in the water. If I stir it, then the diffusion process will be faster. Okay, and without stirring also you can see already the color of the water becomes inky. It have taken the color of ink. But if I stir it, then the diffusion will be faster. See, with a glass rod I am stirring this, the whole water becomes blue. Okay, so the rate of diffusion will be faster if I use this stirrer. Okay, so that's it. Oh, this is the diffusion of liquid, and for solid, if we use it doesn't show any diffusion, as there are strong intermolecular force in between the solid particles, so that will not diffuse. Okay, so for solid we are not going to get any diffusion. So and diffusion will be, from this we can easily understand that diffusion is maximum in gases, as there are a lot of space in between the particles of gas, and intermolecular force of attraction is least, so diffusion will be fastest in gases, and in liquid we are going to get moderate diffusion. If we start it, the diffusion will be faster, and for solid there will be no diffusion at all. So here I am going to end this activity class for today's, after this only. So till then you must try this at your home. This is one, and another, you just be careful whenever you are doing this at your home. Be careful. Okay, whenever we are going to do any chemical experiment, any experiment, you must be very very careful. Okay, so do that in that way. Okay, up to this, have a good day. Thank you.